Hey guys, happy Monday. So today we're going to be going over DNA, protein synthesis, and mutation. We're going to take some really quick notes here, and then you're going to have the vast majority of today to practice. Alright, so the first thing that we're going to go over is DNA. So DNA, remember, is a double helix structure. Kind of looks like this, like a twisted ladder. So it's a double helix. Alright, DNA, or deoxyribonucleic acid, is in fact a nucleic acid, which means that its monomer, or its building block, is a nucleotide. Now remember, nucleotides have three parts to them. So a nucleotide is made up of a sugar, that's the deoxyribose part, a phosphate group, and a nitrogenous base, or a nitrogen base. Alright, so nitrogen base. This is just one of the parts of a nucleotide. The four nitrogen bases are adenine, thymine, guanine, and cytosine. And the way that I just wrote them is how they pair with each other. So, remember that A always goes with T and G always goes with C. So that's your little review of DNA. Alright, next. Whew, this was such a fun topic. We went over it during the year, and that is, of course, protein synthesis. Alright, so the reason that we had to go over DNA first was because DNA is, in fact, the first part of making a protein. So remember, the central dogma of protein synthesis is DNA to mRNA to protein. DNA's main function is to control what protein is made. What protein is made basically controls all of the functions that happen in your body. They control like what you look like. So proteins are like traits. So the first part of protein synthesis is transcription. So transcription is DNA to mRNA. This happens in the nucleus. The second part is called translation. And this happens in the cytoplasm, specifically in the nucleus. Oh, my God, what am I saying? Specifically in a ribosome. Remember, ribosomes are like protein factories. Alright, so step one is transcription. That's when DNA is coded into RNA. It's just like translating into another language that the ribosome can actually understand. So DNA is like one language, RNA is another, and RNA is actually the language that the ribosome understands to translate it into a protein. And the reason also that we need to transcribe into mRNA is because DNA, it can't leave the nucleus. Remember, DNA has to be protected because it's the most important part. So it needs to be transcribed into RNA because RNA can actually leave the nucleus and go to the ribosome in the cytoplasm. Alright. A quick thing that I want to go over. This is something that I feel like we got really confused on. And I wish I had said it earlier in the year. And that is transcription versus replication. Alright, so transcription, I'm sorry, you can't see anything that I'm writing. Transcription, remember, is DNA to mRNA, whereas replication is simply like a copy. You're just making DNA into another copy of DNA. So what that looks like, so a lot of the time in questions they'll give you a sequence of DNA. Alright, so let's take an example. A, T, C, G... Oh, A, T, G, G, C. Great. I'm going to write that on both places. Alright, so same sequence. This is asking me to transcribe it, which means that I'm starting with DNA, and then I'm going to end with RNA. Alright, if this is asking me to replicate it, I'm starting with DNA, and I'm ending with DNA. So in replication, I know that bases pair A to T, G to C. Same thing. The difference here is when we go from DNA to RNA, A no longer pairs with T, it pairs with U. G still pairs with C though. Alright, so if I'm going through here, and I know this is DNA simply because I see thymine in it, so if you ever have a question about that, if you see thymine, you know it's DNA. If you see uracil, you'll know that it's RNA. So I'm just going to go through. A pairs with U because I'm transcribing it to RNA. T, A, G, C, G, C, C, G. Awesome. Alright, here, if I'm making DNA to DNA, A is still going to pair with T. T, A, G, C, C, G. Notice my difference is really just here. Alright, so that's transcription versus replication. The last thing that I said I'd go over is mutation. Yes, mutation. Alright, so we have something called a point mutation, and these are just changes in DNA. That's all a mutation is, a change in DNA. However, when this change occurs in DNA, a lot of the time it creates kind of like a domino effect of what kind of protein is going to be made, right? So if I'm altering the instructions, which are in DNA, then I'm literally going to alter the protein that's being made, and this can have from no effect to like a really major effect in what happens. Alright, so point mutation would be like substitution. Okay, wow, I cannot spell. Substitution. Okay, so that's like one base for one base. So that's like if I had a sequence, I would plug like a G for a C or something like that. G for an A. Doesn't matter. Alright, the other thing I have is a frame shift mutation. Okay, frame shift mutation literally shifts, like it says, the entire reading frame. So let's say like I had, and then I'll go over, so you can have deletion or insertion. Okay, so deletion, remember I take one, and insertion I add one. Alright, so I'm going to take the sentence like the cat. Okay, so if I were to delete one of these, remember things are read in 3, so if I were to delete one, let's say I delete the T. Okay, let's say I delete the T. My new sentence is heck at. I have no idea what that means. Alright, let's say that I add one. Alright, let's say that I add a T to the beginning. Alright, so let's say it's T, T, H, E, C, A, T. So this is the ekati. Again, have no idea what that says. It makes no sense. Hence, I shifted the entire reading frame. I shifted how I read this DNA sequence, which means that when we translated it, when we transcribe it and translate it into these different protein languages, then the protein itself may not make any sense either. Alright, so the rest of the time you have is to practice, reference these notes. You have a computer, use the internet, it's a great thing, and have fun. Let me know if you have any questions.